In last class, we completed electric heating. Today, we'll see electric welding. So, we are discussing about electrical utilization. So, first form of utilization is light. That is, the electricity is converted to light. Then, electricity converted to heat. Now, the electricity may also use it to do some welding works. So, you may get one doubt. Welding without electricity also welding is there. So what is the importance of this welding? Okay, is it not? Other forms of welding is also there. Gas welding, some thermal welding, some other forged type of welding. So out of all these weldings, this electrical welding has got some importance. Okay, some advantages. Why? Because in suppose gas welding, we need to store the gas. Okay, so precise heating may not be possible. So controlling may be a little bit difficult. Similarly, in thermal welding, we need to produce a large amount of heat. Very big furnace has to be set up. We need to store the fuel. We need to continuously give the inputs. Okay. Suppose one particular temperature is required. In normal welding, it is not possible. In case of electric, so we can set a precise temperature, precise welding. Okay, continuous welding. Okay, automation is also possible. So with the help of machines, we can do some automation in the welding process. Okay, so this welding is again similar to what heating. Welding అంటే ఏంది? So in order to join, welding means it is a joint. So in order to join two metal pieces, we are heating that joint at a high temperature, and we are allowing some joining element like some lead, like some bronze, like some other. Okay, joining means two metal plates, plates are two metal pieces. They themselves won't join. So we'll add some other material so that will melt quickly and that will make a bond between the two metal pieces so that that metal piece behaves like a single piece. Okay. Forging, in case of forging means manufacturing of some knives, manufacturing of some other articles. There, two metal pieces are joined by allowing, by subjected to very high temperature as well as high pressure, continuous heating, and continuous metallic uh, stresses. I mean, metallic forces, mechanical forces, so that that metal becomes into a single metal. But in case of normal welding means two metal objects, its a shape, its a size, they won't be affected. Simply they both brought together and we are just heating one particular point. Then some additional adding element. Okay, some metal uh, quickly melting durable material that we are putting in between so that will melt faster and that will join. This is normal process. Here in case of electric welding, there are some types. Electric welding is classified as resistance welding, arc welding, electron beam welding. Okay. So in resistance welding, classified as spot welding, seam welding, projection welding, butt welding. In case of butt welding, again two types: upset butt welding and flash butt welding. But the name is butt welding. Similarly, arc welding, carbon arc, tungsten arc, atomic hydrogen arc, metal inert gas arc, then finally electron beam welding. So out of them, the most popular welding is resistance welding. We all using electrical vehicles, right? I mean, normal vehicles, two wheelers, four wheelers. So how that chases, the skeleton part of the vehicle is manufactured. It is not made up of a single component, single metal piece. So a group of metal pieces are welded in a proper shape so that that skeleton part will be manufactured. So in that group of metals, how they are connected, nothing but it is being welded. So in that particular welding, we use electrical welding. So what are the advantages of electrical welding? There is no much time required to get welded between the two metal pieces. Time required is less. Okay. No maintenance, less space required, efficient welding, faster, better joining. Okay. So there are some advantages are there. So out of which these are the classifications. Then first we will see uh, resistance welding. So in resistance welding, a heavy current flows passes between the metals to be welded. So the heavy current flows through the joint. Then because of that heavy currents, heat is developed. That heat high square losses. That high square losses are subjected to some particular time. Within a short period, heavy currents will flow so that this much heat is developed. Suppose you wanted to heat some larger cross-section area, thicker uh, um, pipes to be welded, then we will allow the current for a larger duration. So we will just increase the time of current, then more heat will be developed. So where heat is nothing but power into time, heat is energy, energy power into time as per our losses, power losses, then time. Okay. So generally this how much current is going at the order of 500 to 5000 amperes. For smaller applications, it is 200, 300, 500. The welding current is always in the order of hundreds. Minimum is hundreds. Our normal loads are 5 ampere, 10 ampere, 230 volts. But here, the welding current is more than 100, 200, 300, 500. Sometimes it is 5000 ampere. But the voltage is less. The welding voltage is less, welding current is more. So like that, the welding transformers and welding generators are designed. Okay. మనం అప్పుడప్పుడు చూస్తూ ఉంటాం కదా వెల్డింగ్ చేసే ప్లేస్లలో. సో వెన్ దట్ వెల్డింగ్ ఈజ్ అండర్ ప్రాసెస్ ఇట్ విల్ మేక్ స్పార్క్స్. But a person who is working, he may touch that electrode, he may touch that uh, welding gun, but he won't get shocked. Why? Because this is lesser voltage at the order of 5 volts, less than 10 volts. But current during the welding, this 5 volts is sufficient to create a spark, and this heavy currents will maintain the arc at heavy temperature so that the welding rod, okay, welding electrode will melt and it will form a permanent welding. So in this resistance welding, first one is spot welding. Spot welding means you can see in this figure. So this is one electrode, movable electrode. This is another electrode. This is flexible electrode. So depending upon the pieces to be welded, so we will adjust this movable electrode and it is supplied by a step down transformer. As I told you, our welding transformers are specially designed to carry heavy currents at lesser voltage. The cross section area of the conductors also more, and its design also little bit more because these are not continuous duty transformers. They are operated with short duration. నార్మల్ ట్రాన్స్ఫార్మర్స్ అంటే కంటిన్యూస్ పవర్ ఇన్పుట్ ఇస్తాము అవుట్పుట్ తీసుకుంటాము కంటిన్యూస్గా నడుస్తూనే ఉంటుంది. బట్ ఇన్ కేస్ ఆఫ్ వెల్డింగ్ ట్రాన్స్ఫార్మర్ the power goes from primary to secondary only during welding. Welding, how much time it is going to continue? Within some 4-5 seconds. Again stop. Okay. When you move this electrode to the other electrode, then only sparks will come. Some welding is going to happen. Then again remove the electrode. Again it is idle. Okay. The operating time is lesser with the order of some seconds. Okay, small duration. So it is designed in a special way. Okay. So this spot welding, it is drawing about 5000 amperes of current, but voltage is less than 3 volts. Okay. So open circuit voltage is about 10 to 12 volts, but during the welding process, that voltage will fall. We all know that the welding transformer characteristics. Okay, initially this is a voltage, and then it will fall. Okay. As the welding current increases, voltage decreases. Okay, like this. Voltage is here at 10 volts or 12 volts before that welding started. Once the arc is struck, current increases and voltage decreases. It comes to 3 volts, 2 volts. At that voltage, it is being maintained. So, what is the application of this spot welding? It is used in the manufacturing walls, welding sheets, fabricating sheet metals, mechanical strength is higher. Okay. Generally, these are used to manufacture some boxes, some container where waterproof, uh, airproof, okay, containers. Such cases, we use this spot welding. Next one is seam welding. In spot welding, only one point of joint is there. Okay, where exact spot where the weld is required, there only we will apply this welding and we will create welding. Okay, spotting. In case of seam welding, the instead of electrode, a series of spots is needed that is produced because of rollers. Electrode is a roller with sharp edge. So it will be used to do the continuous welding. So the two sheets are welded or passed in between the roller electrodes. Steam welding produces a continuous or intermittent steam weld near the edge of the two overlapped materials by using these roller electrodes. Okay. So this is a seam welding where the welding is continuous welding is required. Okay. So such type of continuous welding like as I told you, airtight containers, watertight containers. Uh, in that continuous welding is needed. There we use this seam welding. So as you can see, this is the roller. This is another roller. Okay. So these rollers are placed two sides of these two metals, or two metals to be jointed, two sheets to be jointed. That is placed in between these two rollers. One is fixed roller, another one is moving roller. So these two rollers can be adjusted. Then supply is given. So we are applying some mechanical force and some mechanical power. So these rollers are moving the object which is to be welded. That is also moving, and a continuous welding will be takes place. So in order to cool this continuous operation, so we are using some cooling water. So immediately that welding joint will be uh, gets cooled and becomes permanent. So in this welding, the speed of object, how fast the object is moving, that is also adjusted. So that number of welding joints, I mean welding spots, can be adjusted per inch per centimeter like that. Okay. So usually intermediate flow of current, so that the seam weld is actually a series of overlapping spot welding. The number of spots per centimeter vary between 2 to 4. Okay. So the seam welding is nothing but a series of spot welding, continuous spots. So these continuous spots, how can we achieve? By continuously allowing turning on the transformer, turning off the transformer. So continuous spot weldings will come. So as the number of times the spot increases, the welding spots will increase. As the speed decreases, number of spots increases. Okay, like that. It is used to make up large and lap and butt weldings. Okay. It is employed for welding tanks, transformer, refrigerator, gasoline tanks, aircraft, and various types of containers where the oil proof water oil leakage or water leakage uh, are airtight containers. There we use this continuous spot welding, that is seam welding. Next welding is also there, that is butt welding. In this process, two end of pieces are pressed together mechanically to form a butt joint. Current is flowing through the junction of two butting surfaces to produce the heat in the joint. Okay. So here you can see this is one pipe, this is one pipe, this is another pipe. We will apply mechanical force in this direction. So both metal pipes are under pressure and we will apply the supply to both sides. Then at the junction of these two pipes, because of this not perfect contact, the resistance, contact resistance is more. So the I square loss is also more. Okay. So we'll see this offset butt welding. In this type, the metal piece has to be welded or fixed in the clamps and butted squarely against each other. Heavy current is passed through them. Heat is obtained by contact resistance of the metals to be welded. If then sufficient heat is developed, the pieces are rammed by force to complete the weld. So by heating as well as by applying high mechanical pressure, this welding is being taken. Okay, pressure is applied either manually or with some toggle mechanism. The voltage required is 2 to 8 volts and the current varies from 50 amperes to several hundred amperes depending upon the job, depending upon the resistance, the current will vary. So this is upside butt welding. These are used for joining rods, wires and small pieces suitable for welding the metal parts or end-to-end parts. Is it now? End-to-end parts can be welded with this offset butt welding. Another method is that is flash butt welding. So in flash butt welding, there is a flash. Flash means sparks. In offset butt welding, there is no flash. Here there is a flash. That is the one major difference between the two butt weldings. So here it is a flash welding. In this welding, current is applied to metal parts before they brought together, so that when they meet, the flashing or arcing takes place. This arc continues till the two ends of the metal reach welding temperature. As soon as the temperature is reached, the current is shut off and the pieces are rapidly brought together under considerable pressure, which forces metal and slag out of the joint, making a good solid weld. In previous case, offset butt welding, there is no flash. Only current is flowing through the joint, temperature is rise. Then, because of this high pressure, they both join. In case of flash, there is a flash. So because of this, they come to higher temperature at very faster rate, and mechanical pressure is applied. But this is a little bit lesser compared to previous case. In the previous case, heat is developed but not up to the melting point. Here, because of this flash, these two metal pieces can be welded up to the melting point. These are employed in production work, particularly in welding rods, pipes, okay, welding chains, rail ends, rolled section, shaft axles, like that. Also used in assembling bars, tubing, and sheets. That is the uh, three forms of weldings, resistance weldings. One is spot welding, that is spots welding like a spot. Seam welding, that is a series of spots. In that we use rollers. And next, butt welding, two types, that is upset butt welding and flash butt welding. In upset butt, there is no flash. In flash welding, there is a flash. In upset welding, high mechanical pressure and lesser current. Temperature rises to up to some extent only. In case of flash, the temperature rises up to melting point. High mechanical pressure is applied. The time taken to welding is also lesser. Next one is electric arc welding. Okay. In electric arc, this is the usual welding process we may see in the day-to-day life. Some electrode holder, in that there is the electrode. So where we have electric arc welding. So in this we are creating an arc with the help of high electricity flowing between the two metallic contacts. So because of this arc, higher temperatures can be achieved at the order of 3500 degrees centigrade can be achieved. So with this high temperature, the uh, joint where the welding has to be taking place, we're using one electrode through which the current flows through that joint, and that electrode melts. There is no mechanical pressure is employed. Okay. Applying mechanical pressure is difficult. We need to have some higher mechanical pressure providing sections, chambers. That is very costly. So in this case, there is no external pressure is applied. So we are allowing a current to flow through an electrode, and the electrode is such that first we will place this electrode nearer to the joint. Just we will touch the joint, then starts current flowing. Then we will hold the electrode a little bit higher, okay, just away from the joint, so that there is no direct contact, but current tries to flow through that air gap, which eventually creates an arc. Okay. So here there is no external pressure, mechanical pressure is applied, but during this process that electrode will melt, and that will hold the joining the two components. Electrode కరిగిపోయి ఆ జాయింట్ లో ఫిల్ అయిపోతుంది. Then these two metal pieces forms as a single section with the help of this joint. Okay, so we'll see here. In this method, heat is obtained from arc struck between the electrode and the metal to be welded. The heat developed is utilized to melt the part of workpiece and the filler metal and thus from the joint. And the metal piece heat అవుతుంది, as well as the filler and the two metals జాయిన్ చేయడానికి it need not be a metal parts itself to be melted. Okay, we are using this electrode as a filler material that will melt, and that will go into the joint, and it will form a good bond between the two metal pieces. Okay. Here you can see this is a welding plant, welding generator or welding transformer. This is one electrode. This is another electrode connected to the workpiece. So the circuit is not closed until you touch this electrode to the workpiece. So when you touch this electrode to the workpiece, since it has a lesser open circuit voltage, until unless you brought it to the very nearer or just touch that workpiece, then only current starts flowing. Once the current is flowing, immediately you have to remove that electrode and hold it above the workpiece about 1 mm. Okay, 1 mm or 0.5 mm, 2 mm like that. So just touch and hold above the workpiece. So that current starts flowing by jumping from electrode to the workpiece. So during this process, the arc will struck. So this arc will naturally produce heavy temperatures that will melt the electrode and heat the workpiece. So by heating the electrode will melt and go into the joint, and by heating the workplace, it will it will hold that melted welding electrode. So electric arc has this negative resistance characteristics. That means as the current increases, the voltage decreases. So as I told you, this welding will have this type of characteristics. Current increases and its voltage decreases. Okay. Negative resistance characteristic. So in this welding, AC, DC both can be used in arc welding. So the sparking voltage is about 80 to 100 volts, but in case of AC, that is 60 to 80 volts in DC. So in DC, that for lesser voltage only sparks will come. The arc is struck at 20 to 30 volts is only required to maintain it. So once the arc is struck, in order to maintain the arc, lesser voltage is sufficient. But in order to produce the arc, sufficient voltage is required. Okay, that's why open circuit voltage, before welding, the voltage may be 50 volts, 60 volts. But once the welding is under process, welding is happening, at that time heavy currents flow, which will reduce the voltage. Now the voltage falls to 20 volts. During voltage falls to 20 volts, but before the welding, voltage is 50 volts, like this. In order to produce the arc, this voltage is required. But once the arc is produced, to maintain the arc, lesser voltage is sufficient, that is 20 volts. So here, the common methods of arc welding is metal arc welding and carbon arc welding. So in metal arc welding, the metal rod of same metal being welded used as an electrode. This electrode also serves as a filler and no separate filler is used. Metal arc అంటే మనం ఏ మెటల్ని వెల్డింగ్ చేయాలనుకుంటాం అదే మెటల్ వాడతాం. Suppose if you want to bronze, welding the two bronze materials. So we are using bronze as the electrode. Iron. If you want to melt some copper. So use copper electrode like that. No separate filler material is used. When DC or AC supply is given across the job, electrode arc is struck between two pieces. High temperature will melt that electrode, and electrode will melt and will be deposited into the joint. After that melted electrode gets cooled, it will permanently join the two pieces. So usually 50 to 60 volts DC or AC supply is employed for this type of welding depending upon the job, and current is about 30 to 600 amps. So lap joint means this one only. These two pieces placed one over the other, and from the side we are making a joint. Okay. The corner where the electrode can access that particular joint, that particular portion of joint can only be welded. ఒక ప్లేట్ పైన ఇంకో ప్లేట్ పెట్టాము, ఈ రెండింటికి జాయింట్ ఎక్కడెక్కడైతే ఎలక్ట్రోడ్ యాక్సెసింగ్ ఉంటుందో అదే పాయింట్లో మనం వెల్డింగ్ చేస్తాం, దట్ ఈస్ ల్యాప్ జాయింట్. సో we will require more current than the butt joint in the same material. So this metal arc welding preferably used for repair the broken parts of machine such as steel, cast iron housings, frames, gear wheels, pulleys. ఇట్లాంటి వాటిల్లో అదర్ డిపాజిటెడ్ మెటీరియల్ కాకుండా సేమ్ మెటీరియల్ యూజ్ చేస్తాము. అందుకోసం ఇది దిస్ టైప్ ఆఫ్ మెటల్ ఆర్క్ వెల్డింగ్, మెటల్స్ మాత్రమే యూజ్ చేస్తాం, సపరేట్ ఫిల్లర్స్ యూజ్ చేయం. ఇట్ ఈస్ ఆల్సో ప్రిఫర్డ్ ఫర్ అన్ఇంపార్టెంట్ వర్క్స్ అండ్ ఫర్ మెటల్ డిపాజిషన్ ఆన్ రైల్వే వేగన్ వీల్స్, ట్రావెలింగ్ క్రేన్ వీల్స్ లైక్ దట్. సో ఈ జనరల్గా జరగవు మెటల్, మనం అన్నీ కూడా ఎలక్ట్రోడ్స్ యూజ్ చేస్తాం. సో మనం ఐరన్ని వెల్డ్ చేయాలన్నా ఎలక్ట్రోడ్ని యూజ్ చేస్తాం. వేరే దాన్ని వెల్డింగ్ చేయాలన్నా ఎలక్ట్రోడ్ని యూజ్ చేస్తాం. సో సేమ్ మెటీరియల్ ఉన్నప్పుడు సేమ్ ఎలక్ట్రోడ్ని యూజ్ చేయం. సో దిస్ ఈజ్ యూజ్డ్ ఇన్ దిస్ స్పెసిఫిక్ కేసెస్ ఓన్లీ. And carbon arc welding. So we will continue this from this in the next class.